So I guess you can see my screen, right?
Yes, I'm seeing it very well.
All right, beautiful. So I'm going to go to creating new circuits now. All right, that's fine. So you can see I have something similar to what you have there, all right? So
Yeah, that's true.
yes, so now before going into building the whole project, we have to learn how to program each and every single component that makes up the whole the project we are about to do, right? Now, each of these components have a set of instructions that we need to feed them to be able to function, right? For instance, the LED needs to be controlled. We need to tell the microcontroller when the LED needs to come on, right? Now, for instance, let's say you have a vehicle, because what we want to build is similar to a vehicle, right? Now, let's say you have a vehicle and you're driving. You want your vehicle to come, your headlights, right, or your headlamps to come on when it's nighttime, or probably when you want to see clearly, right? So you put it on, but at this point is an automatic control. So we need to tell the microcontroller when the LED should come on. That would require us writing some sets of code, right? So we are going to start with the basics in the sense that we're going to start with programming the LEDs. Those are the simplest things we can program in the project we're about to do, right? So we are going to start with programming LED. And of course, I said LED stands for light emitting diodes. So basically,
Yes.
the plan is that today would see how we can program possibly every individual part of the robot. Then tomorrow we would bring them together and see how we can create the vehicle, right? Using everything we've programmed and learned today. I don't know if you understand me, sir.
Yeah, I'm understanding.
All right, that's good. So before I continue, we created two links, right? So in case this meeting goes off, that means our time has expired because this is a free version of Zoom. So I created two links. So immediately this goes off, please let's join using the second link. I don't know if that is clear.
Yeah, it's clear. Very clear. Thank you.
All right, no problem. Okay, so the first thing we'll do now is to connect our LED, right? So we have a list of components that we need to do. First of all, we need to make use or employ the use of the brain of the system. And from what my description or my explanations yesterday on the group, I said the brain of the system is the what? The microcontroller, right? So the
Mm.
microcontroller we are using is called the Arduino, and I explained why we are using the Arduino. Arduino is a very easy to use system. It's also open source. That means you can go online, you can make researches and make adjustments to whatever code you're saying, right? So it's very easy for beginners, and you can also use it at advanced level to develop a nice project. Arduino has several and different type of boards, right? So it doesn't matter the kind of board you have, just that some have capabilities that some don't have, right? But the Arduino Uno is very good and very versatile, especially for beginners, right? I'm already having a notification that my meeting will end in 10 minutes, but that's no problem. Please don't forget to join with the second link when this goes off. All right, so first and foremost, we'll bring out um, the Arduino Uno to the worksheet. Now, aside from this, when I click this, it goes in, and what you have is the worksheet, right? This is where you make all your connections. You bring out your component from there and place it there. So let's go one after the other, step by step. So the first thing I want to bring out is my Arduino Uno microcontroller, right? So at this search bar, just click on this search bar. Okay, I think some persons have joined us. You are welcome. uh Please, because of time, we have to start, so hopefully you can just catch up from where we are now. I posted some minutes in the group. Are you there? Can you hear me, or the new guys that just joined? Please signify if you can hear me. Just say hi, please. Can you hear me, the new participants that we just had?
Yes, I'm getting you clearly.
Okay, I think that's still Mr. Daniel. All right, let me continue. All right, so go to your search bar and type Arduino. type Arduino, you will see the option Arduino Uno R3. Can you see that on yours?
Yes, I'm seeing.
All right, so just click on it and you have the Arduino there. You have the Arduino Uno R3. So you're going to left click on it and drag it out. While you left click on it, drag it out. Just use your mouse tab and drag it out to the worksheet, right? You can also reduce the size and increase it. Just put your two fingers on your mouse tab and just reduce it. Bring them together. Draw your fingers closely together and you can reduce or increase it, right? You can change the size. So I'm going to reduce mine. Have you been able to do this?
Yeah.
Okay, that's good. That's good. So this is how the Arduino Uno board looks like. I sent this to the group when I was explaining the components. Of course, I guess you saw this, right?
Yeah, I saw it.
Okay, good, good. Now, if you look at this board closely, you'll notice that it has about three sections, right? The first section at the top is called the digital section, right? The digital section. At the bottom, we have the analog section and we have the power section, right? Don't worry about this demarcation here. These two pins are all digital pins. That's why the line down there covers the both of them and you have digital written there, right? So beneath it, you have analog and power, right? So without wasting much time, I'm just going to rush through the explanation on what those pins are meant to do. Now, the digital pins are meant to give out and receive digital signals, right? I hope you have your book and your pen so you take down notes on any important thing I'm saying because this is a brief
Yeah.
class. Yes, so the digital pins basically are used to send out and receive digital signals. And digital signals are signals that basically have two states. They operate on two states. When I mean they operate on two states, they can either be on or off. They can either be high or low. They can either be one or zero. So basically, digital signals are binary, right? Digital signals are what? Are binary. They operate on binary functions. While the analog are continuous signals. The analog signals are continuous signals. So for instance, if you want to work on if you have a signal that is continuous, for instance, let's say speed, you want to work on a signal that has to do with speed, right? Now you know speed, you don't just put it on and put it off. When you start when you start your car, for instance, you need to start at the lowest speed, right? Gradually you change your gear and you increase the speed to a higher level. Am I correct?
That is true.
All right, good. So that is basically how the analog signal works. Another example is the volume. The volume on your TV set, on your radio, or whatever. You gradually tune it from a lower level to a higher level. That is basically how the analog signal works. Then we have the power section. The power section basically is where you receive and you supply power to what? To the circuit in general, right? So if you want to power the Arduino, you can power it from the power pins, right? That's basically what those three sections are all about. Another thing I would like to draw your attention to is the points where you can power the Arduino Uno board. There are three major points where you can power the Arduino Uno board. Three major points. Take note of these 3 points because after now you might get this board and you might want to work on it. So there are 3 points you can power your Arduino from. The first point is called the power jack. The power jack or the USB jack, right? You can see it on the screen is already connected. It's showing you that something is connected there. Now, if you see this sign here, it tells you that that's a USB, right? So that is basically the point where you also send in your code, but you can also power your board from there. When you plug it into a USB terminal, possibly your laptop, you get your board powered. Another point is called the AC adapter in, right? The AC adapter power in. So when you have an adapter, an AC adapter, this one you plug to your socket, right? It has a rectifier, right, that converts it to DC, and it uses that in powering what? The board. Then from the power pin, we have a pin called the V in. I'm going to enlarge this now. Now the first pin you have here is the V in pin, VIN, which stands for input voltage, right? That pin is also used to power the Arduino. So if you are using a DC source, if you are using a DC source like a battery, right? If you're using a DC source like a battery, you connect your battery. Your battery has basically two terminals, your positive and your negative, right? So you connect your positive terminal of your battery to V in, and you connect the negative to GND. GND stands for ground, right? And you connect every negative voltage or you supply from the DND pins. We have about three of them on the Arduino. We have about three of them on the Arduino, three GND pins. We have one here on the digital axis, and we have two here on the power axis. That makes them three. So please take note of this. We have three digital pins, three GND pins on the Arduino. We have 14 digital pins, 14 digital pins, 0 to 13. That makes it 14. D0 to D13. Those are the digital pins. We have six analog pins, A0 to A5. So depending on the kind of signal you need or you require, you connect these components to such pins as the case might be. Are you there, Mr. Daniel?
Yes, I'm here listening.
All right, that's good. So I think it will be wise of us to just switch to the next link, right? Since because this is about going off, so it won't get us halfway. When we join on the other link, we'll now go straight into connecting because we'll have just 30 minutes to work, right? So we'll just go straight into connecting the LEDs and writing the codes to make it work. So basically, we'll learn how to program the LEDs today. Hopefully, if we still have much time, we can program a few more things before the time rounds up. So let's just join through the second link, right? Thank you.
Yes.
Okay, sir.
All right. So now the next thing we are going to be doing is to bring out the LEDs. You know, we want to actually control the LEDs. Let's see how we can program the LEDs and make them work automatically, right? So I'm going to bring out an LED. So the same way we typed the Arduino Uno, let's type, I don't even need to type. As you can see, I already have an LED here, right? So just hold the same way you brought out your LED, bring out your Arduino, bring out your LED, right? Let's work with one LEDs for now. Subsequently, we can add more and see how it works, right? So we're going to bring out one. You can see the LED has two terminals, the cathode and the anode, right? Now, this basically stands for cathode stands for negative and the anode stands for positive. That's just basically what it means, right? Good. Now, if you have a real LED with you, basically most of the LEDs are designed in such a way that the anode is longer than the cathode. So you always notice that the terminal of the positive or the anode is a bit longer than the cathode. You can use that to identify them. Here, you notice that the anode is a bit curved, right? Good. So that's it. Now we'll also bring a resistor. We'll also make use of a resistor in this scenario, right? Let's make use of a resistor so as to limit the voltage or the current entering into our um, LED, right? So I'm going to bring this out now, right? Then I'm going to adjust this. If you notice, there's a dialog box that comes. This dialog box gives you the opportunity to label these components you are working with, right? So I can decide to label this as my resistor. I can just name this resistor. You can label this and choose the amount of resistance you want. You can, if you click this, you notice that you can make it nano ohms depending on what you want, right? Micro ohms, milli ohms, ohms, kilo ohms, mega ohms, giga ohms. You just make use of the one you want, right? So for this, I'm going to be using 220 ohms, right? I don't need much resistance. So I'm going to be using a 220 ohms resistor. You can decide to use um, uh, a higher one, but just that you know that the output may not be as much as when you're using a smaller one, right? The higher the resistance, the lower the voltage supplied, right? That's from Kirchhoff's law, right? All right. Can you hear me? Are you there, Mr. Daniel?
Yes, I'm here. I'm following.
All right, that's good. So we are going to be connecting this resistor to the positive, right? That's our anode,
Mm,
right? We're going to be connecting the resistor to the positive terminal of what? Of our LED, right? So
mm,
now we're going to choose a pin number for the LED. We're going to connect this positive terminal of our LED to a pin number. But before we do that, we have to first of all ask ourselves, what kind of signal do we want to achieve from the LED? What kind of signal do we want the LED to produce? Now, we want the LED to come on at some point and go off, right? How many states does that make it? How many states will the LED have when it comes on and go off? How many states has it achieved?
true.
2 states. That's good. 2 states because it comes on and it goes off. So what signal are we going to use in this case? What signal pin are we going to use in this case?
We are going to use digital.
A digital signal. That's nice. A digital signal pin. So we are going to be connecting the LED to a digital signal pin. So I'm going to connect my anode to pin 2. Let me just use pin 2. Good. Now, before we continue, I would like to say something about these 2 pins, the D0 pin and the D1 pin. Now, if you notice, these 2 pins are labeled TX and RX. TX stands for transmitting, RX stands for receiving. Now, these 2 pins are special pins. These 2 pins are special pins, and we basically use them when we are dealing with serial communications, like the Bluetooth applications and so on and so forth. So for cases like this, we will not be making use of these 2 pins. So you can make use of any pin from pin 2 to pin 13, right? So just pick a pin number and connect your LED to. So I've used pin 2. So you can pick any pin number and connect yours to. Are you there?
Yes, please.
All right. So what pin number did you connect yours to?
I connected to 3.
All right, fine. Good. So this is your cathode pin, right? So we are going to connect the cathode to our negative pin on the Arduino, which is the what? The GND. So I'm going to use this pin. Just click on it, bring out the wire, and take this to GND. You can use any of the GND points, right? You can use any of the GND points. So are you there?
Yes, please. I'm here.
All right, good. Now, for the purpose of physical learning, I'm going to show you how to connect a battery to a connection like this. So click on your search bar and type battery, right? Now you see a 15-volt battery, a 9-volt battery, and so on and so forth. Now the Arduino has a capability of, please take note of this, if possible, write it down. The Arduino has a capability of taking in 7 volts to 12 volts. It has a voltage range of 7 to 12 volts, right? It has a voltage range of 7 to 12 volts. So if you want to power your Arduino, you look for a battery that gives you an output voltage of basically from 7 to 12 volts. That would work well with your Arduino. So I'm going to click on 9 volts because 9 volts falls in my range, and I bring it out, right? So I brought out my battery, 9-volt battery. Have you brought out yours?
Yes, please.
All right, good. So I'm going to switch this. I'm going to turn this. Now this is the icon you can use to turn this. At the top of your icon bar, your toolbar, you would notice this icon rotates. So you can use it to rotate your battery. So I'm going to rotate it so as to be able to get the pin. I want my pins to be this way, right? You can also switch it. This point is positive, this is negative. If you like, you can switch it, right? And you have here as negative and here as positive. So we connect the negative to the GND as usual, right? Connect the negative to the GND as usual, negative of the battery. And then we'll connect the positive to the VIN as I explained earlier, because this is a DC source. A battery has two terminals, right? The positive and the negative. So the positive goes to VIN of the Arduino, the negative goes to GND, right? So with that being said, we have connected this. Okay, if just give me a minute, please.
Okay.
All right, fine. So we have connected this. Are you still seeing my screen?
Yes, I'm seeing it very well.
All right, good. Okay, good. So that's all with the connection, right? So now we'll now move on to writing our code. So you can now click on code, right? Click on code. You'll see this, right? You see this block. Have you done Scratch before? Have you heard of Scratch programming before? Scratch.
Not yet.
Okay, not yet. Okay, fine. Scratch programming is a kind of programming that are basically used by kids or children, right? They use it to learn how to program. So instead of writing codes, they use blocks like this. They just arrange blocks. You can see how these blocks are arranged. The blocks have their codes that have been written, and each blocks have been programmed. So instead of writing codes, you just pick and drop. But that's not the one we'll be using, right? Because we are not really kids, right? So you go to blocks, go to the selection that has blocks, click on it, click on the selection that has blocks, right? And you see text, just text alone. Click on text, and it will ask you this: are you sure you want to close the block? Continue, and you have this. Are you here?
Yes, please.
Okay, that's good. That's good. Now, this is very important because the language we are using here is called embedded C, but it is a subscript of C++. At the top, you'll notice where it is written C++ code. So this programming you're going to learn here would also help you to understand C++ better. So when you get engaged in learning C++, or maybe you come in contact with C++, you won't have much issues programming or executing such codes. So now, the first thing I would like to explain on this before we before I continue, have you learned any programming language before? Have you learned programming before?
I've not learned any programming language before.
Okay, good, good. Don't worry. I'll explain as simple as I can, right? Now, just take note of these points as they will be coming. The first point is the Arduino programming, right? Basically has three sections. Basically, that means they can have more. So basically, we have three sections on the Arduino programming. The first section is called the declaration section. The declaration section. The second section is called the void setup. The second section is called the void setup. Then the third section is called the void loop. Now, I want you to do this. I want you to highlight this where you have pin mode and backspace it. Remove it. This is just a default code that has been written. I want us to write as again. Now, what I want you to leave on your screen is void setup, this coily brace below it, and this coily brace next to it. Then the void loop and these two coily. This is just what I want you to have on your screen. Have you done that? Okay, good. Because when you have your Arduino IDE, when you have the software on that's the Arduino IDE, what you have is this. You only have the void setup and the void loop, right? You don't have any code popping up anywhere. So all you just need to do is to fix in your code into where they're supposed to be. All right, so those are the three sections of our code: the declaration, the void setup, and the void loop. Now, the first thing you need to do here in your code is to what we call declaration of variables. You need to first of all declare variables. That is, it's a process of telling us what are you making use of and what pins are you connecting them to. Do you understand? So for instance, I want to make use of an LED. You need to declare the LED. Tell us that, okay, I'm making use of an LED. Then tell us the pin, assign it to the pin number, what we call assignment. You use an assignment operator, the equal to sign, and assign it to the pin number you've connected it to. That is what you do there. Now, in declaring a variable, take note, you need what we call the data type and the variable name. Before you declare a variable, you need what we call the data type and the variable name. Just like the name data type sounds, it just tells you the kind of data that is stored in the variable, right? The LED that we are going to be using is basically the variable, right? That's what we'll be using as the variable. Then the data type that we'll be writing before it just tells us what kind of data is stored in the variable. So I'm going to be using a data type called integers, int, and I will explain why I'm using that. So just write int, give a space, and I'm using an LED. So int LED or integer LED equal to, I used pin 2, so you assign it to the pin number you used, right? Let me give a space so it will be more clear. Pin 2, right? For you, you use pin 3 since you made use of pin 3. Then put a semicolon at the end. After doing this, put a semicolon at the end. You always terminate your line of code with a semicolon. It's just like full stop in English language. Anytime you write a sentence, you put a full stop. So you put a semicolon at the end of your code. Now, integer is an example of a data type. When a variable such as this is connected to a number or is assigned to a number, you use integers as the data type. We have other examples of data type like strings. When you use string, you only use string when the variable contains words or they are assigned to words. You use characters when the variable are assigned to letters, and so on and so forth. So we have different types of data type, right? I would I'll drop a note on that in the group so you can understand more about data type. But for the purpose of this practical, we are using int for now. Let's use integer since we are using numbers, right? Since we are assigning the variables to numbers, so we use integer. So int led is equal to 2. Is that clear enough?
Yes, please.
All right, good. So that's all for declaration. Now click inside your void setup. That's in between these two curly braces. These two curly braces are just like baskets. They are used to hold an executable code. So if you want to have a code that should be executed, you write it in between these curly braces. Now the void setup, what the void setup actually does is to initialize or activate a pin number. Let's say for instance we are using a pin. You have to tell us or tell the Arduino if the function you want to carry out on that pin is an output function or an input function. So by doing that, you have activated that pin. So in this case, we want the LED to what? To turn on or turn off, and that will happen when the Arduino sends signal to what? To the LED, right? So when that happens, the LED comes on, and that function becomes an output function, right? Because the Arduino is giving out data. It is only input when the Arduino is receiving data, but since the Arduino is sending out data, it becomes an output function. And the function we use in declaring that is called the pin mode. So you write PIN in lowercase, put a capital M, right? And put ODE. Pin mode is one word, but the M in the middle is a capital letter, right? When you've done that, open a normal bracket. Open a normal bracket. And in that bracket, what do? The first thing we do is to write either the variable name or the pin number. So you can write LED or 2. Since you've assigned LED to 2, this is just like saying X is equal to 2. Then anywhere in your code you see LED, you can use 2. Anywhere you see 2, you can use LED. So I'm going to be using LED, put a comma, right? And tell us what function is it carrying out. In capital letter, you write output. Output in capital letter. Output. Now, if this has been done, that's all. You've declared and initialized your LED as an output, right? So we now move to the void loop. I'll be a bit fast now because of the time. So we'll be able to finish this practical before time runs out. All right. So now this is the stage. The void loop is actually, we're just like the name loop. Loop actually means when something goes round and round, right? Good. So in the void loop, we write the main code. That is, it will continuously execute. It will keep executing until you put off this board. Whatever code you have in the void loop, that is what will be happening. So we want our LED to be blinking. That is actually what we want. We want the LED to blink. And for it to blink, we want it to come on, stay for some time, and then go off, right? That is basically what we want it to do. So there's a function to do that. If the Arduino wants to send out a digital signal, we use the function called the digital write function. The digital write function. This is when the Arduino is sending out digital data. If it is receiving digital data, we use the function called the digital read function. So similar to the analog signal, if it is receiving analog data, it is analog read. If it is giving out analog data, it is analog write, right? So in this case, we are going to be using digital write because the Arduino is sending out digital data. So we use digital write. In brackets, you put your variable there. What do you want the Arduino to send data to? To the LED. And what do you want the LED to do? You want it to come on. So in Arduino programming language, you use high to turn on a device, right? You use high. You know, we say the digital signal has two states, ones and zeros. So if you want to achieve a one state, you use the code language high, right? To tell it to come on. Of course, I hope you can notice my semicolons at the end of every line. The semicolon and put. So always put your semicolons, right? So after that, you press enter. Enter, we now tell it how long do we want it to stay on. How long do we want the LED to stay on? Let's say I want the LED to stay on for 1 second. We use a function called the delay function. A delay function. And I put 1000 in the brackets, right? Put 1000. Now, this delay function, this 1000 signifies 1 second in real time. So that means if you want it to stay for 5 seconds, you use 5000. Right? So 1 second, 1000 in Arduino time is equal to 1 second in real time. So take note. So delay function just tells it how long you want that signal to continue in that particular state. So now we have to turn it off. We've turned the LED on. We want to turn it off. How do we do that? Similar to this, I'll just copy this and paste it because the difference is not quite much. We are still sending out data from the Arduino. The only difference now is that we want to put it off, no longer on. So I'm going to change this high to what? What are we changing this high to? If one is low, beautiful. So we change this to low, right? So we are no longer having ones and zeros. So ones and zeros have been replaced by high or low. So that's basically how you write the code, right? Have you been able to write this?
Yes, please.
Okay, good. Now, since this has been done, we'll just move on to simulation. Now at the top, after your code, the next option is start simulation, right? Good. So you just click on start simulation and let's see how this works. Now click on code so your code part will go in. While it is simulated, click on code so your code part will go in. If you look at my screen, you will notice that the LED is blinking. I don't know if yours is blinking that way. Can you hear me?
Yes, please.
Is your LED blinking like mine?
No.
Okay. Are you done with your code? Are you done with your code?
Yes, please.
Okay, good. Now, can you share your screen? Let me see your screen fast before our time runs out. Let me stop sharing. So share your screen. Let me see what you've done so I can make corrections and make yours work.
It's okay, please.
Yeah. I'm waiting for you to share your screen.
It's okay. I'm doing it.
Okay. All right, that's good. Okay, can you just hold down your left mouse button and draw your diagram down to this way so we can see it. Just hold it down. Hold down your left mouse button and drag it down this way. Hold it down and drag. No, not there. Good. That's better. That's better. Okay. Good. So your connections are fine. Oh, now look at your battery. Look at your battery. The positive of your battery was connected to GND. So click on it. Click on that red line. You're supposed to connect the positive side to VIN. Yeah. So click on that wire and press delete on your laptop. Click on that wire, press delete. Good. Click on the next one and press delete also. Or you can just change it from there. Good. So now draw the red, connect the red or the positive to VIN. Connect it to VIN. Click, click, good, good, good. Now connect the next one to GND, the negative to GND. Good.
If it cross, is it okay?
You said?
When it cross like this.
No, yeah, it's okay. It's okay. It's not connecting at all. Just go, click, click and go. Yeah, good. That's okay. Fine. Now let's go to your code and see what you've done. All right. Int let 3, let output. Good. Good. All right. So run this. Let's see. Click on start simulation. No, start simulation at the top. Yeah. So click on your code. Click on that code. Click on code. Click on the code option so it can take these codes in and we'll see it. See what is happening. Good. So can you see your LED now?
Yeah.
Good. So this is basically how you blink an LED, right? So you can actually write a lengthy set of code and tell the Arduino when to control the LED, right? So this is just a simple way of blinking the LED. So if you want to stop your simulation. So I'll just show you a few things. Click on your code, bring out your code once more, bring out your code. Good. Now, if you want to add more LEDs to this, you know what you need to do, right? You need to declare more LEDs. Let's say you want to add 2 more. You need to declare 2 more LEDs. In your void setup, you have to activate 2 more LEDs, right? And don't forget, you can't use the same name. If you've used LED here, if you want to use another LED, you have to change the name. For instance, let's say you name them LED1 and LED2, right? So there will be no confusion between them. So you give them different names and different pin numbers. So let's say you want to name another LED, you can name it int LED2 equal to 4, right? Can you hear me? Good. So on your pin, on your void setup, you also state the pin mode, right? You initialize the pin by adding another pin mode and make sure you take note of these different names. Similarly to your void loop, all you need to do now is repeat the same process we've done here twice for your second LED, right? Is that clear?
Yes, please.
Okay, good. So that will be a task for you to do, right? You will show this to me first in tomorrow's class, right? I don't really mind if I have just a student. So long as the student understands what I'm teaching, I'm very comfortable and I'm very happy. Thank you for
really grateful.
Thank you for having this time to join the course. It is not actually a cheap course, right? It is something students pay a lot of money to learn from us. But I just decided out of my free will to give out this, to do this for free. And anyone that feels anyone that wants to join is actually free to join. Take the opportunity, and this can be a startup for you to dive into the tech space, right? So I wish you all the best. So please practice this, try and see how you can add more LEDs and make this work. Tomorrow when we come, we would discuss better and see how we can add up more things to what we've done today. In fact, tomorrow's class is going to be very fast. If I still have just you in the class, then I would move straight into building the whole car, right? And we'll program it together. Yeah, thank you very much. See you tomorrow.
Thanks so very much, please.
Yeah, you're welcome. Please just do one thing for me. Are you following my page on Facebook?
Yeah, on Facebook, yeah, I'm following.
Okay, that's good. That's good. So one thing I would just like you to help me do is drop a comment in our group, right, on how the class went today. Just drop a comment in the group. Thank you very much. See you tomorrow.
All right. Thanks so much.
All right, you're welcome. Have a great night. Yeah, bye.
Have a good night.